Okay children, now we are going to see example 1.7 of your NCERT. So what is the question here? Consider the charges Q, Q and minus Q placed at the vertices of an equilateral triangle as shown in figure. So this is the equilateral triangle which is shown in the figure, and the sides of the equilateral triangle are being given as small l. Okay, right? And we have placed the three charges Q, Q and minus Q at the vertices of the triangle ABC. Okay children, right? So all the charges are of same magnitude Q, Q, Q. Only difference is the third charge is differing in sign, that is it is a negative charge. Okay, right? Shown in the figure. What is the force on each charge? Okay, right? They have asked you to find the force on Q1, force on Q2 and force on Q3. Okay, so what have they asked you to find? They have asked you to find the force on Q1, force on Q2 and force on Q3. Okay, so let's find one by one. See, this problem, even though they have asked you to find 3, it's not so big. Okay, because see, the magnitude of all the 3 charges are same, so this makes the simple problem simple for us. Okay, right? So first of all, let's find out the direction of the 3 forces. Okay children, right? So see, let's consider the Q1 charge first. So when you consider the Q1 charge first, Q1 is positive, okay, plus Q. So as Q1 is positive, Q2 is negative, what will be the force on Q1 due to Q2? Q2 is also positive, so Q1 will be repelled by Q2. Okay, so Q1 will be repelled by Q2, that will be along this direction. Okay, right? Q2 is going to repel Q1 along this direction, whereas Q3 is negative charge, Q1 is positive. So what will Q3 do to Q1? Q3 will attract Q1 along this direction. Okay, right? You know that the force will be always acting along the line joining the 2 point charges, right? So that's why this is along this direction and this force is along this direction. Okay children, the resultant of these 2 forces, right? So this is a force and this is also a force, right? Force due to Q3 and force due to Q1. Okay, right? So now the resultant of these 2 forces, right? Okay, resultant of this and this force will be along this direction. Okay, the resultant of them will be along this direction. Now what can I do children? I can complete a parallelogram here. Okay, right? So see, this is a parallelogram. Okay, right? So first of all, let's calculate the total force on Q1 due to Q2 and Q3. Okay, so let's see. So now first of all, let me calculate the force on Q1 due to Q2. Okay, force on Q1 due to Q2, right? This is how you write Coulomb's vector form. Force on 1 due to 2. So what this will be equal to? 1 by 4 pi epsilon naught Q1 Q2, right? Q1 Q2 Q Q. So Q square divided by the distance between the charges, that is your L square. Okay, right? And the direction of this is along what? BA. Okay, BA unit vector. Okay children, right? Similarly, what will be the force on Q1 due to Q3? That will be equal to 1 by 4 pi epsilon naught. Again Q and Q, magnitude of the charges are the same, so Q square divided by the distance between the charges is L, so L square. The direction of the force is along AC, so AC unit vector. Okay, so see, for both the forces, magnitude is the same. Okay, right? 1 by 4 pi epsilon naught Q square by L square. Magnitude is the same, only the direction is differing. That's why while writing here, I didn't write F21 and F31. It is your F. Okay, right? You will find that this F21 vector will be equal to, sorry, no need to put vector sign, because if it is a vector then I will have to write the sign notation. So F31 will be equal to F. Okay children, right? Similarly, let me find the total force. Now let's find the resultant, right? The resultant of these two forces we have not found. Am I right or not children? Resultant of F21 and F31 we have not found. So see, now I have completed the parallelogram, right? I have made it to be parallelogram. So the resultant of these two forces will be the force acting on Q1 due to Q2 and Q3. Okay, so now this is a parallelogram, right? So hope you remember your parallelogram law of vectors. So from the parallelogram law of vectors, what will be the resultant of these two forces? That is F1 vector will be equal to, hope you remember the formula children. So if P and Q are the two forces, P and Q are the two forces, then what was our resultant? Then the resultant will be root of P square plus Q square plus 2PQ cos theta, right? This was the formula for the resultant of the two forces P and Q making an angle theta with each other. Okay, right? Here also these two forces are making an angle theta with each other, and how much is this angle children? This angle will be equal to 120 degree. Okay, right? So write according to the parallelogram law of vectors. So root of, instead of P and Q you have F and F, right? So what can I write? F square plus F square, right? F square plus F square plus 2 F into F cos of 120 degree, right? The angle between the two forces is 120 degree. So 120 degree, and see the direction of this force, right? I have written the vector form. Am I right or not? Right? So the direction of this force will be along, see, this line and this line are parallel to each other. Okay, so instead of writing like this, instead of writing a new notation representation and writing, I will be writing this is along BC vector. Okay, this is along BC vector. Okay children, right? So now this works out to be equal to F plus 2F square plus 2F square again, and what's the value of cos 120? That is equal to minus 1 by 2 BC unit cap, right? 2 and 2 gets cancels off, and I will be getting 2F square minus F square along BC. So this is going to be equal to how much children? Root of F square, that is equal to F. Okay, the direction of the force will be along BC, right? This will be the force on Q1 due to Q2 and Q3. So we have found F1. Okay, so now similarly we are going to find the expression for F2. Okay, we are going to find the expression for F2, right? So what is F2? F2 is the force on Q2 due to Q1 and Q3. Let's find the direction of the forces, and then we will calculate the force. Okay, right? So now see, Q2 is positive, Q1 is also positive. So this Q1 will repel Q2 along this direction. Okay, again I am writing F only children, I am not writing F1, 2. Okay, because see, magnitudes are the same. So you will find that the magnitude of both the forces will be the same. Okay, magnitude of the charges are same, so magnitude of the forces will also be the same. Okay, only the direction of the forces will be differing. Okay, so Q1 is going to repel Q2 along this direction. Now Q3 is going to negative charge, no, so it will be attracting Q2 along this direction. Okay, right? Now again the resultant of these two forces, right? We have to find the resultant of these two forces. The resultant of these two forces will be along this direction. Okay, right? Again I can complete it to be a parallelogram. Okay children, right? Now see, what is the angle between these two forces? These two forces, angle between these two forces is equal to again 120 degree. Okay, right? See, listen carefully. Force on Q2 due to Q1 will be same in magnitude as this, because magnitude of the charges are not differing. Again, force on Q2 due to Q3's magnitude is also going to be the same only. Okay, right? And now see, the angle between these two forces were 120 degree. Here also angle between these two forces will be equal to 120 degree only. Okay, right? So I can write simply, instead of sitting and calculating the F2 value, I can just write simply that F2 vector will be equal to F. Okay, right? If you want, you work it out, you will find it to be the same. Okay, only thing is the direction of the force will be different. Okay, so now see, what is the direction of the resultant force? So now this is your F2 vector. Okay, what is the direction of the F2? F2 is along this direction. Okay, what is this direction? Parallel to AC. Okay, what is this direction? This is parallel to AC, right? So I can write the F2 force is acting along AC unit cap. Okay, children, so we have calculated the value of F1, direction of F1, value of F2 and direction of F2. Okay, what else is remaining? F3 alone is remaining. Okay, so now to calculate F3, first of all, let's find the direction. Okay, so Q3 is here, negative charge. What will this positive charge do? This positive charge will attract the negative charge towards itself. Okay, so this is your force. Okay, similarly, this positive charge will also attract this negative charge that will be along this direction. Okay, right? Now, what is this whole angle? You know that this whole angle will be equal to what? This will be equal to 60 degree. Okay, whole angle will be equal to 60 degree. Okay, right? Now, the resultant of this force and this force is going to be along this direction. Okay, resultant of these two forces will be along this direction. So this is your F3 vector. Okay, this is your F3 vector. Okay, children, right? So now we have found the direction of F3. Now we have to calculate the magnitude of F3, right? So for calculating the magnitude of F3, only one thing will be different, that is angle between the two forces will be different, right? So here the angle between the two forces was 120. Here also the angle between the two forces was 120. Here the angle between the two forces is equal to how much, children? This is equal to 60 degree. Okay, not 120, this is equal to 60 degree, right? So let me write. So what will I be getting? F3 vector is equal to root of F square plus F square plus 2F into F cos of 60 degree. Okay, and the direction of this force will be along, see, this is your C. Am I right? This is your C. Let me represent this F3, that is, it is along AO, CO, right? So this is along CO. Okay, right? So where do I get the parallelogram here? See, I have used parallelogram law of vector, so there should be a parallelogram, no? So this will be a parallelogram. Okay, right? So the resultant will be along CO. Okay, children, right? So what this will be equal to, this will be equal to 2F square plus 2F square cos 60 is equal to plus 1 by 2, you know. So 2 1 2 get cancels off along CO. Okay, this is going to be equal to 2F square plus F square 3F square, and this is equal to what? Root 3F. Okay, so here F3 vector will be equal to root 3F. Okay, right? So this is the value for F3, this is the value of F2, and this is the value of F1. Okay, this is how you have to find the force on each charge. Okay children, right? Hope you have understood. If you have any doubt, you can ask me in the comment section. Okay, I'll explain it in my next class. Thank you children.